Hello and welcome to today's lesson. Today we're going to look at an old friend known as the parabola. So, I've put one that you might already know how to graph on the board. And I'm going to just refresh your memory. We'll look at that and then we'll look at a few twists and turns. First of all, what you'll see is a lot of times they like to take this -1 and bring it to the other side, and I'll just show you why that is. You might think, well, that's silly. It's not how I learned it last year or whenever. But if you think of it this way, it's a little bit more consistent with the shifting the way it is for ellipses and circles and hyperbolas. In other words, I look at this and I go, okay, I'm ready to graph. What I see here is on the x's, I want to shift to +3. And on the y's, I want to shift down to -1. So in a sense, it's a much more consistent way of thinking about your shifting. Now that I've got the shifting out of the way, the nice thing with a parabola is that tells me where my vertex is. So I'm just going to make a little note that the vertex is at 3, -1. And the next thing I have to do is decide, okay, what kind of a parabola do I want to graph? Do I want one that opens up, or should it open down? How wide should it be and how narrow? Now, lots of people have different ways of doing this, but the way I like to do it is, I just think of this thing here as the origin. Think of it as 0, 0, and I ignore my shifting. And I say, well, this is the parabola that I want to draw at this location. And so all I need is 1 or 2 little guide points, and that tells me exactly the way it's going to open and how wide or narrow it should be. So I do a couple of very simple points, like if x is 1, well, 1 squared is 1, times 2 is 2. Okay, well now I go 1 to the right, corresponds to going up 2. Okay, so I know it opens up. And because parabolas are symmetric, I can see that I'm going to have, if I went 1 to the left, I'm also going to go up 2. And that pretty much tells me I've got a slightly narrower parabola here. So let's just draw that. And there's my graph. Okay, so I don't need to get too fancy. Very nice, easy way to figure it all out. One other thing that's often asked for is, I mentioned symmetry. They'll often ask you for this line here. This is the line that kind of splits the parabola into 2 mirror images, and that's called the axis of symmetry. And often you'll be asked for its equation. Well, this is a vertical line, so you want to put down x equals, and in this case we're going through an x value of 3, so there's the equation for the axis of symmetry. Okay, well, that's our first example. Hope it brings back some very fond, happy memories. In any case, this is standard form, which is the form we like. Sometimes it's not in standard form. So let me do an example of cleaning up a mess that's in general form. Something that looks like this. X squared plus 2x minus 2y minus 5 equals 0. Now, before I even start cleaning this mess up, I just give myself a little bit of a guide, because I look at it and say, hey, there's an x squared and there's a y. So I'm basically dealing with one of these types of parabolas. Now, there's going to be some shifting probably, some narrowing or expanding, widening, but in essence I'm dealing with one of these. Now, why is this a good mental note? Because the standard sort of y equals x squared parabola will either open up or it'll open down. It's not one of those sideways opening to the right or to the left. So right off the bat, I've got kind of a mental image to help guide me through this. So what I want to do now is get the x stuff and complete the squares. kind of group it together. And I'm going to take everything else that's not part of the X stuff and move it to the other side. So let's get rid of this. This is just going on in my mind. So the window on my mind there. So we don't really need to look in there. So I'm going to move this stuff over. I'm going to add the 2y over. I'm going to add over the 5. Okay. Now I'm going to complete the square. I need half of 2, which is 1, squared is 1. Well, I got to do the same to the other side. So now I can factor it. And it looks like so. X plus 1 squared. And over here I've got 2y plus 6. Okay. Well, we're getting there. But what we now want to do is any little extra number that's in front of the y, you don't want that number hanging around. So to get rid of that number, I'm basically going to divide everything by 2. And then I'm going to rearrange things a little bit. Now, we normally don't write it like this. Instead of writing it over 2, we write it with 1/2 in front. And over here, well, what do we have? We have y and we have plus 3. There's one more little thing I'm going to do. I'm going to spin the whole thing around so that it looks the way we kind of like it to look. We have the y plus 3 on the left side and all the other stuff on the right side. Well, there's my equation in standard form. Now it's just a matter of draw the picture and move on. Okay, let's draw this thing. Okay. On the x-axis, I want to shift over to -1. On the y-axis, I want to shift down to -3. So that's where my vertex is. And what I now have is essentially this equation that I want to graph treating this as 0, 0. Well, one very easy point that I can use is if x is 1. If x is 1, 1 squared times 1/2, I would get a y value of 1/2. So that means if I go 1 to the right, I only want to go up 1/2. Now if you want to get fancy, give yourself a second point. Sometimes that really helps to make a more accurate graph. If I put in a 2, 2 squared would be 4. 4 times 1/2 is 2. So in other words, 2 to the right would correspond to going up 2. And that gives me a little bit more of an accurate picture. There's that side, and of course it's symmetrical, so I have pretty much the same shape happening on the other side. There's my parabola, and if I want, I can list all the lovely things like the axis of symmetry, and that is at x equals, and what did we shift? We went to -1. And the vertex is the other important thing you'll be asked for, and that's at -1, -3. So there you have it. Now we're ready for the next example. Okay. Of course, I'm going to throw in some twists and turns. Got to expect these things. 3y squared. Ooh. Minus x plus 6y plus 5 equals 0. Now again, I like to get a bit of an image before I start trying to mess around with it. And what I'm already thinking is, hey, I see a y squared and then an x. Okay? So I'm thinking it's one of these guys. Kind of, the roles have been reversed. So I'm already expecting a parabola that opens to the right or left. Okay? So that's the mental image. So I'm now going to be trying to group all the y stuff together and everything else to the right and so on. So let's see. We'll factor out that 3. So now we have the y squared. We have this plus 6y, so we want plus 2y. Leave a little space, and we'll move the x to the right. It becomes positive x, and we'll minus the 5 over there. Let's get rid of this. so it doesn't confuse us. To complete the square, I need half of 2, which is 1. Squared is 1. But I actually put in a 3, so I have to compensate by putting a 3 in on the other side. What do I now have? 3 times y plus 1 squared equals x minus 2. And if I spin it around, it'll look a little bit more like what we're used to seeing. And there it is. Now the question is, how do we graph this thing? Well, let me write it a little bit lower so that I've got more board space to work with. Okay, so let's get rid of this. And let's get drawing. Well, the shifting works the same. It doesn't matter which way the parabola opens. We're still going to go shifting on the x-axis to positive 2. And on the y-axis to negative 1. So there's no problem with that. And that gives us our vertex. So whatever else, we have a vertex at 2, negative 1. No problem with that. But what about the way this graph should open? Well, again, my suggestion is that you ignore the shift and you say, well, how does this equation behave? How does x equals 3y squared behave? All you need is 1 or 2 simple points, and that will guide you to drawing the correct parabola. Now, when the roles are reversed like this, I find it a lot easier if I plug in y values as opposed to x values. So I'm going to just plug in a y value of 1, squared is 1, times 3 makes 3. So the x value would be 3. Okay? And I could just as easily have taken negative 1. Let's see, I don't want to clutter everything up here. We'll just sort of squeeze it underneath, I guess. If I take negative 1 for the y value, it gets squared, becomes positive 1, times 3 is 3. So an x value of 3. So what I have is these 2 points. Now remember, I'm treating this as 0, 0. So what I want to draw is 3 to the right. So 1, 2, 3. 3 to the right and positive 1. And 3 to the right and negative 1. Okay, so basically it has guided me to going 3 to the right, up 1, 3 to the right, down 1, and poof, there's my parabola. So it's quite a narrow parabola that opens to the right. And there it is. Now the axis of symmetry for this guy is not going to be x equals. That's because we're dealing with a horizontal line as our axis of symmetry. So this is going to be y equals, and we're going to a y value of negative 1. So y equals negative 1 is our axis of symmetry. Well, that's another example now. We'll look at one last example with parabolas. Okay? And in this one, you have to do some detective work. Okay, what we want to do in this example is find the missing equation. We're told that it is a parabola, and we're told bits and pieces about the parabola. We're told that it has a vertex at negative 2, 1. We're told that it passes through this point here at 2, 3. And we're also told that it has a horizontal axis of symmetry. Now, that's enough to show me exactly what it would look like. Okay. Vertex is at negative 2 and 1. So there's the vertex of the thing. It passes through the point 2, up 3. But we're told it has a horizontal axis of symmetry. Well, horizontal means this way. So it means that my axis of symmetry is this dotted line here. So my parabola must be looking like that. So again, the light goes on in my mind, and I'm thinking, yeah, this is going to be one of those x equals y squared type parabolas, and all I got to do is tinker with some of the settings. Well, the only thing I have to worry about really is how wide or narrow it is, because the vertex gives me the shifting stuff. On the x, where did we want to go? We wanted to go 2 to the left. So this should be x plus 2. On the y, we wanted to go up 1. So we want to have y minus 1 all squared. So the only thing I don't know is, and I'll call it k, the number that's in front of the function part here that's going to affect the width or narrowness of the parabola. All I got to do now is plug in the coordinates of a point that's on my graph, and that'll dictate from this little equation what k has to be. So I'm going to plug in a 2 for the x. I'm going to plug in a 3 for the y. And if I do a little bit of solving, a little bit of algebra, I'm going to get 2 squared, so that's 4. And I divide both sides by 4. K turns out to be 1. So it turns out all I have to do is, the number for k here would be 1, so it's invisible. I'll just take it out of there, and there's my answer. Da-da-da-da. We found the missing equation. Okay. Well, I think with that, I'm going to stop for now. Catch you later.